x. Okay. So this was the triangle given to us, and not most of you, at least 2 of you asked me, ma'am, is OG missing? And I said, no, I've deliberately left it out. But when I ask you to find x and y, I'm going to need to know what GT is in order to find what OT is. Okay? So we did that, we proved that they were similar. We went and wrote down what our sides corresponding were. And then we went and wrote down what those values were. TR is 12. ON is Y. RG, then we're asked, do we add them together? Yes. 9 is 6 plus 3. And then NG is 3. Oopsie. TG is X plus OG. And then OG is this missing part, which is actually not X. I made that mistake yesterday. Because TO is actually X. So it's over OG. So I'm glad that I made that mistake because it is quite an easy mistake to make. So make sure you are writing what is asked for. So calculating y was pretty easy because we just took these 2 fractions and cross multiplied. So y times 9 is 9y and 3 times 12 is 36. So dividing both sides by 9 gives me y is equal to 4. So that's fine. So we are going to go onto a new page, because obviously that's now wrong because I was being silly, and calculate what x plus OG is. X plus OG is just TG. Now, because, and hopefully you have the diagram in front of you, because we have a 90-degree triangle, we can use Pythagoras. So TG squared is equal to TR squared plus RG squared. So I'm writing the full Pythagoras proof out now, which I did not do yesterday, so I was lazy. But in a test, if I ask for it, you obviously have to do the full proof. Anyone still busy with the y portion? Can I take it out of view? Okay. So now TG is I don't know. I want to find it. TR is 12. RG is 6 plus 3, which is 9. And then I'm going to square root both sides. TG is equal to, of course you can go and calculate it and find 144 plus 81. 225, so when you square root it, it will be 15. So now that full length of TG is 15, and I'm going to draw it on the diagram so you can see what I mean by the full length. My full length is 15. But my diagram and my sides that are in proportion matches TG to OG. So somehow we need to get x involved there, don't we? So what is this going to be if x plus that must give me 15? No, not quite, almost. There we go, 15 minus x. So what would we write just to confirm that's what we want? Okay, but I'm talking about the step in between and I've lost my page. There it is. Okay, so I know that TG is equal to TO plus OG. I know that TG is 15. I know that TO is x, but OG I do not know yet. So I'm going to make OG the subject by taking x over, becoming, if I take my x over, it becomes 15 minus x. And now I have something that has x in it. and allows me to solve for x. So I'm going to go back. I'm going to go back and fill in the information that I have. My one fraction is 9 over 3. My other fraction we said was TG, which we now know is 15. And OG, which we now know is 15 minus x. And now I can cross multiply and solve for x. What do I need to do with this denominator that's got the two terms? I have to protect it. Now I can cross multiply. So 9 times 15 minus x. 3 times 15 is 45. 9 times 15. I'm going to trust you on that one. I think I agree. And 9 times x.
Isn't it negative x?
9 times negative x, negative 9x.
Yeah, I'm
Okay. Now what? Is x single by itself or even positive?
No.
So we're going to have to do that. Yes, Hannah?
Take 135 over and plus negative 135.
Okay. So what is negative 9x now equal to?
Negative 19. 19 is equal to negative 19. Divided by negative 9, and you get 10 equals 8. So it's a negative 6.5.
Fantastic. So I would say that's probably as difficult as I would make a similarity sum for you. In a normal grade 9 year, which obviously this is not a normal grade 9 year, we would have thrown in quadrilaterals. So we would have said this is a square. Therefore you need to know that sides are equal or diagonals are equal or whatever else and use those properties as well as similarity. But luckily for you, I guess, it's not a normal year, so we are not throwing in quadrilaterals. So it's just basic similarity and basic congruency. So let's look at that question from last year's paper, which I thought was actually quite an easy one, even for a normal year or a non-shortened year. So I'm going to look at, if you watch the recording, it might not show the exam paper, but it is the 2019 paper 2.
Are we doing another similarity?
Still similarity, and after this paper we will look at the cases of congruency. Okay, so there was some geometry, more geometry, more geometry, more geometry, more geometry, and then we got to our similarity question. Okay, so it is very light. I'll darken it on the board. So we have AB being parallel to CB, and then it crisscrosses. Sorry, that's very steep. Forming two angles. O1 and O2. I also get given that this is 4, 8. This is 4, 8. This is 5, 6. This is 1, 2, and this is X. A, B, C, D, and that's O. And then we're going to prove triangle ABO similar to triangle DCO, and we're going to find X. So I'm just going to take that off of the... So you can see that I'm taking it from a question paper, and I'm going to now go back to the document camera. Yes, Hannah?
Ma'am, I'm still not 100% sure how you know which order to do the triangle. Like for example, you go A, B, O, then how do you know to go B, C, O?
Okay, we will look at that. Let me draw it on a folio so we can have it on the document camera, and then I'll show it to you. Okay, so that is what I'm doing. I'm just redrawing it so that it can be seen under the document camera and therefore recorded. So you can draw it so long. And then I will answer Hannah's question, which is a very important question. Okay, is that all they wanted? Okay. Okay, so Hannah asked, how do I know what my second triangle's name is? So in this case, Hannah, they gave me the name. So then I have to use the name they give me. But what happens if they don't give me the name? So how I name two sets of triangles is the following. I always choose the first one. So I choose the name of my first triangle. But I will give you a tip that it's almost always alphabetical. So that's my first step. So my first triangle I just made. My second triangle I now match each letter for letter. But I need to match based on something. Match second triangle name, letter for letter to first triangle name. Based on corresponding properties. What I mean by that is, so I've named my first one alphabetically, A, B, and O. Now I need to match my second triangle. Well, let's look at the corresponding properties of these two triangles. A, B share a parallel line. So the two letters that I'm going to match, A and B, are going to be some combination of C and D. Okay? But now I need to know specifically which combination. Because A matches a letter and B matches a letter. So I'm going to have to look at some other information that allows me to find that. I'm going to use my properties of parallel lines. Using alternate, which means A has to match B. Therefore, B has to match C. What's left? O has to match O. So we do that in all kinds of triangles. So if I have this, for instance, so P, E, and F. Well, A is between a 1 and a 3, so it's either going to be F or E. Okay? B is between the two ones, so it's definitely matching P. So if I name my first one ABC, I'm going to match. I can't quite say what A is yet. I definitely know that B matches P. I'm actually going to need some other kind of information to finalize. So let's say I say that and that. So C matches F, and therefore E has to match A. So name the first one and find corresponding properties for your second one. But more often than not in a test, I actually give you the name. Then you just use the name as is. Okay, so proving that they are similar. So like I said, this was in last year's November grade 9 paper. So how do I start a similarity proof?
In triangle ABO and triangle DCO.
And I didn't even need to think because they told me the two triangle names. Now I need to match three things. In similarity, there are two options. Angle, 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 or?
Side, side.
No, that's congruency.
Oh, side, side, side.
No, that's congruency. Side in proportion. Which one am I going to use here? Angle, angle, angle. So the first thing I can say for sure is that A or O1 equals to O2. There's no confusion. What did I do to say that? Next thing, angle A would be equal to?
Angle C. I mean D.
What is my reason?
Sorry, I think the wrong one. Just turn it angle.
What do I have to mention?
Triangle.
And my last thing?
Angle A. B. Angle C.
Reason?
Okay, angle equal.
What is the other one that I could use?
Third angle and triangle.
So you can use either one, don't give me both, it's a waste of time. Therefore, triangle ABO is similar to triangle DCO, angle, angle, angle. Therefore, first 2 over first 2 is equal to second 2 over second 2 is equal to first and last over first and last. I only started writing this yesterday. So finding x, I'm going to take that AB over DC is equal to BO over CO is equal to AO over BO. Why can I say that? Well, they are similar. And now I'm going to go and substitute. AB is x, DC 5.6, BO
It's just CO.
CO
Is 4.8.
AO
1.8.
and DO.
Is 4.8.
So which two fractions am I going to use to solve for x?
X 5 minus 6 and 1 is 2 over 4.
What do I need to do now? Cross multiply. You'll definitely need your calculator for that. 4,8x is equal to 67.
76. No, 67. 4.8.
I have decimals. So
Um,
5,6 times 1, 2.
6.72.
You were saying 67.
Yeah, I can forget after this.
Okay, now what?
Now you're going to divide both sides by 4.8.
What's my final answer?
1.4. I don't know. Yes.
4 years. 1.4.
1.4. What would BO be if I had to ask you in a separate question? What?
I think it will be 1.2 also.
Why do you say so?
Because in opposite sides are equal because of the CDO because of the according to him,
I think it's 1.2.
Okay, so we said that this angle is equal to that angle, and this angle was equal to that angle. But here we have 4.8 and 4.8, which makes it what kind of triangle? Isosceles, which tells me that these two angles are the same, right? That means that these two also have to be the same, which means that this is also 1.2. Opposite sides are equal to opposite. What? Equal
angles,
sides,
equal
opposite,
sides.
equal angles. It's the reverse because I've used the sides to prove angles.
It says equal sides, equal opposite.
Yeah.
Okay, so we must work out.
You could not, but I think that's a very long way to do it. You could just do this. You could just do cross multiply. 4.8 times 1.2, which is what?
It is 5.76.
Dividing both sides by 4.8. BO is equal to?
1.2.
Did you calculate it?
No.
Calculate it.
5.76 divided by
4.8.
it is 1.2.
Don't assume, actually calculate. So we did do it via geometry. That's equal, therefore that's equal. They were equal, therefore that's equal. But you don't have to take it through geometry. You can just use your similarity as a way to calculate. I'm going to do one more because I realize we haven't actually done proof by size and proportion very often. So we're going to do one of those. Okay, so I'll write that down. Just give me a second. B and C is B and C. You have break first.
Can I clean the board?
Yes, you can, please. Thank you.
Will I clean that one as
You can clean everything. She doesn't like them. Okay, let's do one using sides in proportion. Check something. You guys did this last year.
Did we?
This year was in your November paper.
That looks scary.
But it is still a proof by angles. I'm trying to find a proof by... Okay,
Ma'am, when do you make one up?
I'm going to make one up now.
You want to go? Okay, wait, that's easy. That means DE is 14 and a third. Of course.
Sorry. No, wait, I'm confusing myself here. Do you want to practice the fractions or not? Yes, we'll practice the fractions.
Because you need to practice all ways. And just practice it. You don't have to let it come to struggle. Sorry? What did you say? No, I'm really not. Sitting over there.
The guy that gets funny.
Actually, your best right now is sitting in this class and it's not Caleb.
It's just oh yeah, so she got 100%. Okay.
If we are going on, you're only as good as your last test. If we're going as good overall, then yes, Caleb is your highest.
Yeah. But in the complete class, it's Christina and Logan, I think. The two of them are literally, they've got like a calculator in their brain. Which focuses on thinking. That's a
Okay, so we are going to prove that triangle. Put this a bit higher.
Okay.
So I'm going to give you the names just to make your life a little bit more easy. I give you no angles, I also give you no parallel lines, so angle, angle, angle is not an option.
I don't know how to do this.
So we are forced to do sides in proportion, which means we actually need to know which sides we need to compare. How do we know that from the names of our triangles, Anna?
We go A, B, and DE, and BC, and EC, and then AC and DC, I think.
First two, second two, first and last, first and last. Okay? So I'm going to zoom out so that we can see that written. Okay, I can't zoom out anymore. And then I'm going to actually have to go and find what those values are and go and calculate them. So AB is 15, DE is 5. BC is 20. EC is 6 2/3. And the last one, which you can't see currently, so I'm going to zoom up, or not zoom up, put my page up a bit. AC, I told you, was 35, and DC, I don't know yet, but can I calculate DC?
Yes.
Doing what?
You,
No, not Pythagoras, because there's no right angle.
can't you use, let's say we use Nana, wait, let me just get my words right here. Yeah, so you say, AC minus AB.
So 35 minus 23 and a third. What is my answer?
35 minus 23 and... Wait. Minus 23. This is so difficult to do this on a calculator.
Convert it to improper, it's the best way.
Okay.
Or you can go 35 minus 23 equals minus another third. Which gives you 35 over 3 or 11 and 2/3.
So, 11 and 2/3.
But you can leave it as improper as well, it's not the end of the world. Okay. So we have 11 and 2/3 that we have to minus at the bottom there. So, divide. So 15 divided by 5.
3.
20 divided by 6 and 2/3. Now, be very careful, grade 9s. Because if you go 6, and then you go, let's say, plus 2/3, it gives you an improper. So that is fine. But you can't go 2/3 and then all of a sudden realize you need to put the 6 in front of it. That, your calculator where I just typed in 6 and 2/3 does not see it as a mixed fraction. So be very, very careful. I haven't actually figured out what it's doing, but it is not seeing it as a mixed fraction. So please make sure that you actually do it in improper form, or you can say 6 plus 2/3 will give you your improper form.
So 20 over 3.
20 divided by 6 plus 2/3. Because you need to have the 20 on top and 6 and 2/3 at the bottom is giving me an answer of 3.
Ma'am?
Yes.
I said 6 times 3 is 18 plus 2, so I converted.
Yeah.
And then I just said 20 divided by 20 over 3, I got the same answer, that's still fine.
But remember, you must say 6 times 3 is 18 plus 2,
Yeah.
20 over 3, and then 20 divided by 20 over 3 is 3, yes. So then you can do the same thing here if you wanted to convert it to a mixed fraction, which I will do so we can practice both. 11 times 3 is 33, plus 2 is 35 over 3, which means that I need to trip and times. So I'm doing it completely without a calculator, but obviously you are allowed a calculator. Have we proven that they are similar?
Yes.
What is my reason?
Size in
There we go. What did we say it was? DEC. What is my reason? Sides in prop. Not side, side, side. That is only for congruency. It must be sides in proportion. Now I can say, for instance, C is equal to, let's say, 36 degrees, and A is equal to, let's say, 70 degrees. What is E equal to?
oh, then you gotta work interior angles of triangles. Okay, so
But there's a few steps involved, right? It's not just interior angles of triangle. That's my last step that I'm going to do. So I'm going to put it on my diagram. C is equal to 36. A is equal to 70. And I want DEC. I need 3 letters. I want this angle there. So the first thing, grade 9, you have to note is if I did not know they were similar, I would not be able to do this.
Ma'am, can't you just say, because here, A is equal to, wait, A is equal to B. So then can't you say B is also same to B? And then B is equal to E. Okay, but you don't have B. So okay, ma'am, can say A is equal to D, so D is
So you're saying A is equal to D.
No,
That's B.
okay, now I'm saying A is equal to CBE.
Okay.
Okay, so
Why?
because they're similar.
Okay, so I would write that. I would say that A is equal to BBC. What's my reason? Triangle A, what was it? ABC is similar to triangle BBC. That's my reason. They are similar and that allows me to say it. And now what?
And then you can say angle C is common. Okay, so they'll still say.
I don't need that.
No, I'm thinking it's the thing out.
Now we can do interior
I'm
angle.
getting there. Taking long. The same.
Sure.
What are interior angles equal to?
180.
What's my reason?
Interior angle of a triangle.
And what is my final answer?
106 minus 74.
110 minus 30 is 180 minus 6. Yes. Could I ask this? Yes, I definitely could ask this.
So DEC is 74. 80. Sorry for taking so long, Jessica. I need to wrap my head around what I was doing.
Okay, so we only have about 6 minutes. Our next section of work is congruency. So we just did an introductory note. We're not even going to do our cases, okay? So congruency, everyone remember what the symbol for congruency is?
It's like basically E as a line. It's 3 sideway lines.
Okay, I always think of it as equal with an extra line.
That's
But
what I like.
but the E without the side line is, I guess, the same thing. Okay, so congruency. What am I proving? Well, I'm still busy with 2 triangles. Of what? So if we had similar, they're exactly the same. If they are identical, exactly the same, that means that they have to have the same corresponding sides, the same length, for corresponding sides, and we have to have the same size for corresponding angles. So everything we do to prove congruency, so our 4 cases, must ensure that we have in some way or another proven that every angle, corresponding angle is equal and every corresponding side is equal. So if I have 2 identical triangles, visually I need information telling me that they are the same. So here I have proven, not proven, I'm showing you that A is equal to E, B is equal to D, and angle C is equal to angle F, right? Those are my corresponding angles. But this current information only tells me information about angles. So can I make an assumption that they are equal in size as well?
No.
No, because similarity, we allowed angle, angle, angle. But for congruency, I need at least one information about the size length. The side of the length. The length of the side, okay? I need at least one information about the length of sides. Angle, angle, angle is similarity only. It only proves similarity. we need at least one side. So if you have ever actually analyzed your cases, you would have seen all 4 cases include at least one side length. So I would need to know, for instance, one side length. So here we have 6 options, right? We have 6 options, but we do not prove using all 6 options because we don't always get information for all 6 options. So we only prove using 3 options. So there are 6 possible combinations of corresponding information. That's 3 angle combos and 3 side combos. But to prove congruency, we only need 3. So remember, we only need 3 bits of information to prove congruency, and one of them has to be a side. The others can be more sides or can be a combination of angles and sides. Now there are 4 that we accept. Side, 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 so we have at least one side, that's allowed. Side, included angle, side, we have one side, that's allowed. Angle, angle, side, I still have my side, so that's okay. And lastly, if I have a special right angle triangle, I can prove it using the right angle, the hypotenuse, and a side. That's also got a side in it. So we have to have a side to be able to prove congruency. If you have got no side information, you can't prove that they are congruent. You can only prove that they are similar. So now, next time I see you, we're going to do all 4 of them and practice, practice, practice. So if you have that, you can pack up and we'll wait for that bell. Looks like I've forgotten that it's great.
Remember that isn't any announcement.
Yeah, but then they normally do the first bell for downstairs and upstairs. Sorry if you're still busy, but I don't think anyone was. OneDrive and do that next week when you're at home, but don't do nothing. And then your marks are going to look sick too.
It's fine, I'll wait.
No, it's not fine. You did really well in the last test, you should be doing well in the next one as well. No?
You still need it. I bought you a cupcake.
Thank you.
You want one?
Sorry.
They're not very sweet.
Okay. You can have some of that chicken if you want. It's
No.
just it's cold.
Also have curry.
Okay. Yeah, I'm trying to actually get to filing, but I teach 6 lessons, so it's impossible.
I'm trying to download all my freaking videos and articles.
Oh, good luck with that.
Yeah, my iPad